Hello everyone. On this video we will be looking at higher order derivatives. Okay, so the first one we're going to look at is the second derivative with respect to x. Here's the partial with respect to x of the partial of f with respect to x. Okay. It can also be denoted as the second derivative of f with respect to x squared, which is also equal to partial derivative of x, and then that partial derivative get it with respect to x again. Okay, so really this is just going to differentiate twice with respect to x. Okay. Our second higher order derivative is the second partial derivative of y. Okay, so really all that is the partial derivative of y of your first partial derivative with respect to y. Okay, which is equal to second derivative of f with respect to y, or partial derivative of y and that with respect to y. Okay, so really all you're going to do is differentiate twice with respect to y. All right. Now the third and fourth type of higher order derivative or second order derivative can get a little confusing depending on the, not the definition, but the how it's denoted to you. And I'll show you what I mean by that. So the partial of f with respect to x and then y is really just the partial derivative of y of the partial derivative of x. Okay, so you find the partial derivative with respect to x, and then you take the partial derivative with respect to y of that. Okay, you can also see it as partial derivative of x and then find the partial derivative of y, or the second derivative of f with respect to y and respect to x. Okay, now this is the confusing part. If you look at the terminology and how it's written out, you're going to differentiate with respect to x first, then with respect to y. Okay, now the thing that makes it confusing is that for this notation, you're going to go with x, then y, which is x first, then respect to y. But in this notation, you're going to go right to left. So x, clean that up a little bit, x, then y. Okay, so depending on how it's denoted, you're either going to go left to right or right to left. Okay, and fourth, partial y, then x, that's just equal to the partial with respect to x of your partial of f with respect to y. Or partial with respect to y first, then find the partial with respect to x of that one. Or second derivative of f with respect to y and x. Okay, all of these mean the same thing. Differentiate with respect to y first, then with respect to x. Okay, so I'll leave a little note here for the mixed derivative. Okay, so for that notation, you have partial of x and y, or either partial of y and x. That goes from left to right. Okay, meaning for your two variables, you're going to find the partial for this one of x first, then y. And for this one, you're going to go y, then x. Okay, so you're going to go left to right. But in this notation, second derivative of f with respect to y, or x and y, and the second derivative of f with respect to y and x, you're going to go from right to left. So you're going to go x, then y, and this one you're going to go y, then x. Okay. Now partial derivatives can go to the third, fourth, fifth derivative, etc. And go to the third, fourth, fifth derivatives, and etc. Okay, so it doesn't just stop at the second derivative. You can keep on going, and going. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and go to our first example. Okay, so for example, what if we wanted to find the second derivative with respect to x, the derivative with respect to x, then y, the derivative with respect to y, then x, and the second derivative of y for z equals x squared minus 2xy plus 3y squared. Okay, so the first thing we're going to do is we're going to find the first derivative with respect to x. So the first derivative with respect to x, remember that's just the derivative with respect to x of each term. Okay, now with this one, the 2 and the y are both constants, so you can pull that right out to the front, which leaves the derivative with respect to x of x. Okay, so plus the derivative with respect to x of 3y squared. I'll just leave that together because it's with respect to x, but it's a y variable, so it's considered a constant. So the 3 and the y squared, all constants, so the derivative of a constant is 0. Okay, so we end up with derivative of x squared is 2x. And the derivative of x with respect to x is just 1. So you have negative 2y times 1, which is negative 2y. So the partial with respect to x is just negative Oh, 2x minus 2y. Okay, so that's the first. Now we're going to find the second derivative with respect to x. Remember, the second derivative with respect to x is just the first derivative with respect to x, and then that again with respect to x. Okay, so really that just means our first derivative, which is 2x minus 2y, 2x minus 2y, and you're going to find the derivative of that with respect to x. Okay, so if we apply the partial derivative to both terms, we see that the partial derivative with respect to x of 2x is just 2. The partial derivative of 2y with respect to x, remember that's seen as a constant when you have an x there, so that just becomes the derivative of a constant, which is 0. So 2 minus 0 is just 2. Okay, so that's your second derivative of x. Okay, so now we're going to find our partial of x, then y. And remember, that's just the partial of x, and then that with the partial of y. Okay, so that's just equal to partial with respect to x, which is 2x minus 2y, then that with respect to y. Alright, so we find the derivative of 2x with respect to y. Because it's with respect to y, remember that's considered a constant. So the derivative of a constant is just 0. So that can actually, you can draw that line through that one if you want to. The derivative of negative 2y with respect to y is just negative 2. That's okay. So now we have to find the partial with respect to y, then x. Okay. So the partial with respect to y, remember, we have to find the partial of each, or the derivative of each term with respect to y. Partial with respect to y of x squared minus partial with respect to y of 2xy. Actually, you can go ahead and just factor out the 2 and the x, since those are considered constants. Okay, so you have your 2 and x. Leave the partial with respect to y of just your y, plus 3y squared. You can leave that all together, so partial with respect to y of 3y squared. Okay, so if we do each term, the partial with respect to y of x squared, that's the same as saying the partial of a constant, which is 0, so you can cross that out. You have 2x times the derivative of y with respect to y is just 1, so 2x times 1 is just negative 2x. And the partial with respect to y is 6y, so it's plus 6y. Okay, so now we can find our partial with respect to y, then x. Okay, so remember, that's just the same as saying the partial with respect to y, then that with respect to x. Alright, so that's going to equal negative 2x plus 6y, and that with respect to x. Okay, so if we find the partial derivative of both terms, you see here that the partial with respect to x of 6y is just going to be 0, because that's the derivative of a constant. Okay, so the partial with respect to x of negative 2x is equal to negative 2. Okay, now one more with our second derivative with respect to y. Remember, that's just partial with respect to y, and then with respect to y again. Okay, so that, your partial with respect to y is negative 2x plus 6y, and with respect to y again. Okay, so we go ahead and find the derivative of each term. Okay, so the partial with respect to y of negative 2x, again, that's the same as saying the derivative of a constant is just 0, so that disappears. So we have the partial with respect to y of 6y is just 6. So it's the second derivative with respect to y. All right. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay. Now, before we move on to our next example, I want you to notice something. Go back to the previous page. Okay, if you notice, the partial with respect to x and y and the partial with respect to y and x happen to be the same. That's going to be the case, but only if they're continuous, if your original function is continuous. So as long as that's continuous, those two will be the same. Okay, so in other words, quick note, if your function f of x, y is continuous on an open disk that we'll call R, then for every xy value, f of xy is going to equal f of yx. Okay, but only if your function is continuous. Or f of x, y, z is equal to f of x, z, y is equal to partial derivative z, y, x, and etc. so on. However many ways you can mix those up. This is if you have multiple variables. So that's for f of x, y, z. Okay, so however many ways you can mix those up, they will all be equal if your function is continuous. Okay, so now we can go ahead and go to our example. Okay, so for example, what if we wanted to find the partial with respect to z, x, and z for f of x, y, z is equal to y e to the power of x plus x natural log of z. Okay. Then we want to prove that the partial with respect to, let's say, zxz is equal to the partial with respect to zzx. Okay. So we just kind of mix those up. We want to show that they're the same. Okay, but first we have to find the partial with respect to zxz. Okay, so we find our first derivative, because remember here, we're going to the first one. So the partial with respect to z. Okay, and that's equal to the partial with respect to z of ye to the power of x, plus the partial with respect to z. That x is a constant, so we can pull that out to the front. So partial with respect to z of natural log of z. Alright, so that means the derivative with respect to z, you have a y and you have an x. E is a numerical value, but both of those would be considered constants. So derivative with respect to z of a constant is just 0. Okay, so we know here that the derivative with respect to z of natural log of z equals 1 over z. Okay, so you have x times 1 over z, so a partial with respect to z is just x over z. Alright, so now we want to find the second part of our problem, which is, here we go, circle that, so I want to search for it. We have the partial with respect to z, now we find that with respect to x. Okay, so partial cx is just the partial with respect to z, and that with respect to x. Okay, so our partial with respect to z is x over z. So that's just x over z, and that with respect to x. Okay. And again, the z is considered a constant, so we can pull that out. That's just 1 over z times the derivative with respect to the partial derivative with respect to x. Now remember, they aren't the same. Partial with respect to x of x. Okay. Now the partial with respect to x of x is just 1. Derivative of x is just 1. So you have 1 over z times 1. So that's just 1 over z. Okay, so that means partial with respect to z and x is just 1 over z. So now, do one more. Partial with respect to z, then x, then z. Okay, so all that is equal to the partial with respect to z, then x, and then z one more time. Okay, now we already have the partial with respect to z and x. That's 1 over z. So that's equal to 1 over z. And we're going to take that, find the partial with respect to z. Okay, so the partial derivative of 1 over z with respect to z is just negative 1 over z squared. So 1 over z squared. Okay, so we found our partial derivative. Now, we just have to show that it's equal to partial with respect to z, then x. Okay, so we have the partial with respect to z, that's x over z. So the partial with respect to z, then z is equal to our x over z. Oh, I might as well rewrite that as partial with respect to z, and then with respect to z again. Got that part. Okay, so really that's just equal your partial with respect to z, which is x over z. So you have x over z, and that with respect to z. Okay. Again, that x is a constant, so you can pull that up front if you want to. But the derivative with respect to z of x over z is actually equal to negative x over z squared. Okay. So now to find our derivative with respect to z, then x, that's equal to derivative with respect to z, and then that with respect to x. Okay, so we already found our second derivative with respect to z. Okay, that's negative x over z squared. That's negative x over z squared. So now we want to get that and find the derivative with respect to x. Okay. So in this case, the z squared is the constant, so we can pull that up to the front. Okay, so, well, 1 over z squared. Actually, negative, go with it. So negative 1 over z squared times the partial with respect to x of x. Okay, so this is the partial with respect to x of x is just 1. So that shows us that partial with respect to z, then x is negative 1 over z squared, which is the same as partial with respect to zxz. Okay, so because it's continuous, you can see that those mixed partial derivatives are true. Are equal. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and go on to our next example. All right, so for example here, what if we wanted to find the second partial derivative of f with respect to x then y for of xy is equal to 3x y squared minus 2y plus 5x squared y squared, and determine the value for partial with respect to x then y of negative 1, 2. All right. So to solve this, first thing you have to do is find our partial with respect to x. Because remember, in this form, you go from right to left. So partial of f with respect to x is equal to the partial with respect to x of 3xy squared. And actually, we know since it's respect to x, the 3 and the y squared are considered constants. So we can go ahead and pull those right out to the front now. So 3y squared times a partial with respect to x of x minus partial with respect to x 2y, and I'm just going to leave that like that, plus, we know this is with respect to x, So the 5 and the y squared can come out front. So we have 5y squared times the partial with respect to x of x squared. Okay. The reason I left this one is because the partial with respect to x, the y is looked at as a constant. So the derivative of a constant is just 0. Okay. So the partial with respect to x of x is just 1. So the derivative of x is just 1. So that means that's just 3y squared times 1, or 3y squared. Plus, the partial with respect to x of x squared is 2x. So you have 2x times 5, which is 10x, times y squared. Okay? So now, we use that to find our second derivative. Move that up. There we go. Okay. So remember, that's just equal to the derivative with respect to y of our derivative of f with respect to x. Okay. So we already found the derivative with respect to x. So that's just the derivative with respect to y of 3y squared plus 10x y squared. Alright, so if we find the derivative with respect to y of both of those, let me just continue that down here. That's the partial with respect to y of 3y squared plus, we know the 10 and the x will be looked at as a constant. So we can pull that right out to the front. So we're left with the partial with respect to y of y squared. Okay. Now the derivative with respect to y of 3y squared is 6y. Okay. So plus the partial of y squared with respect to y is 2y. So you have 2 times 10, which is 20. Then you have your x and you have your y. Alright. So we know that the second derivative of f with respect to x then y is the same as saying partial with respect to x then y. Okay, those are the exact same. Okay, so we know that the partial with respect to x and y, xy, is equal to 6y plus 20xy. Let me clean that y up a little bit. There's no confusion. There we go. Okay, so that means at the point -1, 2, move that up some, our partial with respect to x then y of -1, 2 equals 6. Our y is equal to 2. Plus 20, our x is -1. Again, our y is equal to 2. So we just replace all our variables there. Okay, so that's equal to 12. 20 times 2 is 40, so that's minus 40, which is equal to -28. Okay, so that's the partial with respect to x then y at the point -1, 2. Okay, so hopefully this made sense, and I will see you on the next video.